I welcome you all for the topic of recursion C. Recursion is the process of repeating tasks in a self-similar way. This recursion function is only supported in C programming language. Definition: a function that calls itself is known as a recursive function. Here the programmer have to establish an exit condition. Once the condition is true, the recursive function has been called in a recursive way. If the condition is false, it comes to the remaining statements and the program ends. What is the reason we are going to establish the exit condition? If you are not establishing the exit condition, the recursive function goes to the infinite loop. How does recursion works? In a program, we have a one main function, one recursive function. From this main program, we have a function name called recurse. Once a recurse has been called, the recurse function starts working. Here we can see how the recurse function has been repeatedly called. What is the use of recursion? Recursion makes the code smaller. Any data structure problems can be easily solved using recursion. Advantages of recursion: for a recursive function, you only need to define the base case and recursive case, so the code is simpler and shorter than an iterative code. Some problems are inherently recursive, such as graph and tree traverses problems. These two problems are from the concept of data structures. These two problems have to solve only using recursion. That is much more efficient here. Disadvantages of recursion: a recursive program has greater space requirements than an iterative program, as each function call will remain in the stack until the base case is reached. It also has greater time requirements because each time the function is called, the stack grows and the final answer is returned when the stack is popped completely. I'm going to see an example program, sum of natural number using recursion. Here we have a one main program, one recursive program, the recursive function name is sum. I'm going to get the input to the variable number. Now we're going to call the function name sum, going to pass the actual argument number with the input of 3. Once a recursive function has been called, the formal argument copies the values from the actual argument. The 3 is copied to the n. It comes to the condition n not equal to 0. It checks the condition n not equal to 0, 3 not equal to 1. If the condition is true, the return n. Now n is 3. The return n works, the stack has been created. The value 3 has been pushed to the stack. Here the stack is a temporary storage. It is like a buffer. It is created only by the compiler when the recursive function has been called. Now plus sum n minus 1. N is 3 now. 3 minus 1, 2. The function passes the value 2 now. The recursive function call has been made. Once again, checks the condition. 2 not equal to 0, condition becomes 2, return n. Now n is 2, when the return n is executed, it pushes the value to the stack as a topmost element. Okay, 2 is now topmost element. Now plus sum n minus 1. 2 minus 1, 1. Once again the recursive function has been called. Sum passes the value 1, check the condition 1 not equal to 0, like that. The recursive function has been called repeatedly in a recursive way. Once the condition becomes false, the stack pops the topmost element and get evaluated what is the final result. It returns the final result to the main program. It is copied to the variable result. Now the sum equal to 6 is the final result for the input n equal to 3. Let's see how the stack works. Here the main program calls the function sum. It passes the value 3. How the condition has been checked here, we can verify that. N not equal to 0. 3 not equal to 0, condition becomes 3 true now. Return n. Now the stack is created. The value 3 has been pushed to the right. Push is the insertion operation. Now the 3 is pushed into the stack. N minus 1, 3 minus 1, 2. Once again the function has been called, 2 has been pushed to the stack, and then 1 has been pushed to the stack. Like that the recursive function calls. When n becomes 0, the condition becomes false. What happens now? Now the pop operation works. Pop is a delete operation. Okay, similar to a delete operation. The pop operation pops the topmost elements from the stack. Okay, now what is the how it works now? Stack 0 plus 1 1. Okay, next topmost element 2, 1 plus 2 3. Next topmost element 3, 3 plus 3 6. This is the final result that has been returned to the main program. It is stored in the variable result. Now answer has been printed, sum equal to 6. Okay, this is how the stack works. This is the procedure for the recursive function name sum. Next we are going to see the example factorial of n numbers using recursion. When you see the n factorial, how it works, n into 2 into 3 into 4 up to n. From this factorial program, the input n is 6 here. The recursive function name is multiply number. The actual argument 6 has been passed to the formal argument. Checks the condition. The multiply number recursive function has been repeated call has been made. The final result of the factorial of 6 is 720, that has been printed here. This is the procedure here. Next we are going to see how to execute the next we are going to see how the sum of a natural number works here. This is the program. Compile it. Then it shows the 0 errors. Run the program. Your input is 3. Sum equal to 6. Okay, this is the final result. Next we are going to execute the factorial of n numbers. Compile the program. It's of 0 errors. Run the program. Factorial of 6 is 720. This is how the program has been executed. Any queries? Okay, thank you for all for patient listening of the concept of recursive function. Thank you.